An Italian volcano with a fire-shaped scar down its northwestern flank produced a fresh lava overflow on Tuesday night. And the path it took to the sea has been used so many times in the last 20 years that scientists have stopped counting. INGV Osservatorio Etneo, the Italian National Institute of Geophysics and Volcanology, issued the report on May 26, 2026. Surveillance cameras at Stromboli's summit recorded effusive activity from a lava overflow at the North Crater area. The flow developed along the Sciara del Fuoco, a horseshoe-shaped collapse scar on the volcano's northwestern flank. Volcanic tremor amplitude climbed from medium to high values. Explosion-quake rate and amplitude did not change. GNSS data did not show significant ground deformation. Civil protection alert remained at yellow level 2 on a 4-level scale. This is the second lava overflow on the Sciara del Fuoco in 3 weeks. The previous one began at 21:20 local time on May 4th and reached the sea less than 6 hours later. At least 78 overflows have used this slope since September 2008. This is not a catastrophic eruption. This is not a tsunami warning. It is no longer a routine week at the most active volcano in Europe, but it is exactly the activity this slope is built for. But here is the detail that tells the real story. Stromboli is famous for explosions, small bursts of gas-rich magma ejected from the crater every few minutes, every day, for thousands of years. The activity this week is different. The volcano is no longer just exploding, it is effusing. Lava is leaving the crater as a continuous stream and traveling downhill. That changes the physical question. Strombolian explosions stay near the summit. Lava overflows leave the summit and start running down a slope that has been the volcano's fire-to-sea highway for at least 7,000 years. In Ginostra, the smaller of Stromboli's 2 villages, no road access, reached only by sea, people watch the slope above their homes whenever the volcano produces a new flow. In the main village on the eastern side, tourists who arrived for summer expected to see evening explosions and got a flowing lava river instead. On May 4th, lava reached the sea in less than 6 hours. On May 26th, 3 weeks later, lava is moving down the same slope again. What is new is that this volcano has now used its natural fire-to-sea highway twice in 3 weeks. Stromboli is dangerous not because it erupts rarely, but because it erupts so often that people forget how quickly its fire can move from the crater to the sea. Here is what the Etna Observatory recorded. 3 monitoring channels were active during the May 26th observation. Surveillance cameras showed the effusive activity at the North Crater area, with the lava overflow developing onto the upper Sciara del Fuoco. The seismic network read volcanic tremor amplitude, the continuous low-frequency hum produced by magma and gas moving inside the conduit, climbing from medium to high values. The same network read explosion-quakes, discrete events that fire with each Strombolian burst at unchanged rate and amplitude. And the high-frequency NSS network, satellite positioning instruments across the island, recorded no significant ground deformation. Magma is moving more continuously beneath the conduit. The discrete bursts at the vents are still happening at normal pace. The island is not bulging or contracting in a way that would indicate a deeper magma chamber change. The signature is consistent with an effusive overflow phase, not with a buildup towards something larger. The May 26th event sits on top of a monitoring picture that had already been active. On the morning of May 4th, at 11:21 UTC, INGV-OE reported intense spattering feeding a lava overflow on the Sciara del Fuoco. By 21:20 local time, the overflow activity had increased. By 1 in the morning UTC on May 5th, the lava had reached the coastline. Civil protection has not raised the alert. The aviation color code remains at orange. The volcano is doing more than it was doing in February, but exactly what it has done in previous overflow phases. The question is not whether the report is significant. The question is what the Sciara del Fuoco does with the lava that is now flowing on it. Here is why this matters even though Stromboli erupts every day. Strombolian explosions are the activity that gave a name to this type of volcanic behavior worldwide. Small bursts of gas-rich magma, lapilli and bombs thrown up to 100 meters above the summit. Several events per hour. Predictable enough that tourist boats anchor offshore at sunset to watch them. Lava overflow is different. The magma column inside the conduit rises higher than its normal working level. Pressure builds against the rim of the crater. Instead of being ejected upward as discrete blasts, the lava starts spilling over the rim as a continuous stream. The stream leaves the crater area and starts running downhill. The physical question changes. What does the summit do becomes what does the slope do? The two behaviors can happen at the same time. On May 4th, while the lava overflow was developing on the upper Sciara del Fuoco, Strombolian explosions continued from both the north and central south crater areas. On May 26th, the same thing. The explosions did not stop. The new behavior was added on top of them. Here is what is sitting under that lava. The Sciara del Fuoco is not a slope in the ordinary sense of the word. It is a collapse scar. A horseshoe-shaped depression on the northwestern flank, formed by multiple massive sector collapses during Stromboli's Neostromboli phase. Between roughly 13,000 and 4,000 years before the present. The mountain literally tore pieces of itself off repeatedly into the Tyrrhenian Sea. The Sciara del Fuoco is what was left behind. It runs from near the summit at over 700 meters elevation directly down to sea level. The slope angle is near the angle of repose for hot rock. The slope is not stable bedrock. It is composed of layered lava, lapilli, scoria, and incandescent debris piled up over millennia of eruptions. Every overflow leaves another layer on top. Every collapse rearranges what is underneath. In a 2023 peer-reviewed study of crater collapses and overflows at Stromboli, volcanologists characterized the slope in 5 words: can generate potentially tsunamigenic landslides. That phrase is not editorial. It is a geological description of what this configuration is physically capable of. Unstable. What that instability means in practice is that the Sciara del Fuoco is a conveyor belt for everything the volcano produces above its angle of repose. Lava overflows like the one currently descending it, 78 since September 2008. Falling blocks from the crater rim. Pyroclastic density currents when the rim collapses, analyzed at speeds reaching roughly 40 meters per second. Hot avalanches and debris flows. Thermal anomalies that infrared cameras catch before the human eye does. And the slope does not channel material into open water. It channels material toward the populated northeastern coast of the island, roughly 2 kilometers away. That distance, combined with what the slope has done in the past, is why INGV upgraded Stromboli's monitoring network in 2003 and has not stopped expanding it since. Here is the documented record of what this slope can do. December 28, 2002. Late afternoon. An eruptive fissure opened in the northern part of the Sciara del Fuoco depression at roughly 550 to 600 meters elevation. Lava began emitting onto the slope. The persistent Strombolian activity at the summit was interrupted. The start of what would become the longest effusive crisis in Stromboli's modern history. 2 days later, December 30th. 13:15 local time. The eastern portion of the Sciara del Fuoco collapsed. A landslide of roughly 9.5 million cubic meters of submerged material slid into the Tyrrhenian Sea. 8 minutes later, at 13:23, a second landslide, another 11.5 million cubic meters of subaerial material followed. Total displaced volume across the two events, roughly 20 million cubic meters. The two landslides generated two tsunamis. Run-up heights reached up to 10 meters. Inundation extended up to 250 meters inland on Stromboli's eastern coast. The villages of Paisit, Ficogrande, and Scari took the impact. The waves crossed to the island of Panarea. They reached the northern coast of Sicily, 60 kilometers south. Buildings damaged, boats destroyed, several people injured. 6 evacuated by helicopter to Sicily hospitals. The effusive phase did not stop after the tsunamis. It continued for another 7 months until July 22, 2003. On April 5th, a paroxysmal eruption fired at the summit craters. The lava emission did not pause. The cumulative lava volume across the entire crisis, roughly 11 million cubic meters. The largest effusive event at Stromboli in the past 30 years. Stromboli has produced tsunamis before. The Smithsonian record lists earlier events in 1930, 1944, and 1954. Lava overflows on Stromboli's record have lasted anywhere from a few days to several months. The 2002-2003 crisis sits at the long end of that range. This is not a prediction. This is the documented record of what the Sciara del Fuoco can do when the conditions align. Here is what happens when the lava reaches the water. When lava enters the sea, the temperature contrast is roughly 1100 degrees Celsius against 20, 2000 degrees Fahrenheit against 68. Seawater flashes to steam in milliseconds. Small hydromagmatic explosions can occur, ejecting blocks a few hundred meters from the coastline. The lava continues into the water, fragmenting into pillows and breccia, and starting to build a new piece of coastline. That new piece of coastline is a lava delta. Temporary by definition. Fragmented, partially cooled lava sitting on a steep submarine slope. Waves attack it constantly. Deltas can collapse suddenly, generating additional debris flows. The May 5th overflow built one. The May 26th overflow may produce another. What INGV is watching now, volcanic tremor amplitude. Surveillance feeds, lava feeding rate. Explosive activity at the north and central south crater areas. Thermal anomalies on the Sciara del Fuoco. Slope stability. Knots deformation, and anyone violating the access restrictions on the slope. The question now is not whether the slope is about to fail. INGV has not said that. The question is whether the overflow ends in days or extends into weeks, and whether the slope stays stable while it does. Stromboli is dangerous not because it erupts rarely, but because it erupts so often that people forget how quickly its fire can move from the crater to the sea. One overflow on May 4th, another on May 26th, 78 on the same slope since 2008. 2,000 years of recorded eruptions. One scar that has been doing the same thing the whole time. If this story is worth telling, subscribe. We cover more of these every week.